Okay, all right guys, so to continue, as Liam just got done reading, we were talking about how heat affects liquids, right? And you talked about evaporation and basically a boiling pot of water, and
water vapor.
It turns into water vapor as it goes up. As it gets heated up, it turns into water vapor. And what's another example of that? Around here, and weather-wise, what's an example of water vapor that you might see in the air? Evan?
Air, like
air?
Gas.
Well, yeah, what does that look like though? What's the name? It's a three-letter word.
You can see air.
Well, right. Well, what is it? What is it though?
Well,
3 letters, starts with an F.
Water.
Well, with the water, it gets evaporated up, and so it's in the air now.
Far?
From the ocean, so we get the water kind of evaporates up, and it becomes a cloud that's really low to the ground. And it looks like fog. Yes, yes, that's evaporated water. It's in the air, and it's all around us. That's a really cool thing. Okay, so real fast then, I would like to talk about what you guys would like to know, I guess, a little bit about heat. This is what you want to know and about heat. Is there any, you guys have any questions about heat? What you'd want to learn about heat? Feline?
How does it make you get hot?
How does it make you get hot? Okay, that's good. Okay, and anybody else? Evan?
Sun.
The sun, you want to learn maybe a little about the sun? You might get some solar heat as well.
Solar eclipse.
Okay, to learn a little bit more about this, I'd like to play, well, actually, we gotta learn a little bit about temperature. Does anybody know anything? How do you measure temperature?
By using a ruler.
A thermometer?
Yeah.
A thermometer. You measure temperature by using a thermometer. And what are the two ways of reading a thermometer? Well, there's two different.
The numbers.
The numbers, and those numbers can be either in two different measurements, whether it's Celsius or the one that we all know really well. Starts with an F. Again, we got another F word.
Fog.
Fahrenheit. So we have Celsius and Fahrenheit, and there's definitely different points in there where the water will boil, where the water will freeze, and then your just basic room temperature. In Fahrenheit, boiling water temperature is 212 degrees Fahrenheit. So that's really hot, because when we're outside, the temperature only gets about 100, so we're about 112 degrees short of boiling. So when it's outside, people say, oh, it's boiling out here. Well, it's really not, because it's only 100 degrees. So 212 degrees would be the boiling point. A freezing point, if anybody's been to a really cold climate area, like Minnesota or Alaska or Antarctica, you would know that water freezes,
Or North Dakota.
or North Dakota, or water freezes at 32 degrees Fahrenheit. North Pole, exactly. 32 degrees. That's how cold it has to be for it to snow, right, and freeze and all that. So that's how the water turns into snow. Okay. So now that we kind of have, well, then also on the Celsius side, they measure it a little bit differently. I think it's kind of easier to know how to tell temperature by Celsius because it's very simple. It's not 32 or 212. Boiling water reaches at 100 degrees Celsius. So that's easier to remember, 100 degrees Celsius. Freezing water is 0. So between 0 is freezing and 100 is boiling. That's pretty simple to remember. So if it's somewhere in the middle, around 25, 50 degrees Celsius, you're looking at pretty decent temperature, like 50, 60, 70 degrees, like room temperature. So that's kind of where we want to be at most of the time, to be comfortable, right? So we're going to do a quick little game, since we just kind of went over that, regarding temperature in Celsius and Fahrenheit. And I want to see how well you guys picked up on that. And I want you to tell me about what degrees it would have to be to utilize these articles of clothing. Because if we're going to be dressing ourselves in the morning and we watch the news and they tell us it's going to be 0 degrees Celsius outside, what kind of shoes do you think we would want to wear when we're going outside?
Those boots.
We got tennis shoes, which might work, but it'd still be kind of cold. We got flip-flops. I don't know. It's kind of cold at 0, I think, but and we have these nice winter boots.
Winter boots.
Winter boots, exactly. 0 degrees Celsius, that's what you'd want to wear. Or if they said it was what degrees in Fahrenheit?
0.
If it was like around 32 degrees, the freezing mark, you'd probably want to wear these winter boots. But if the news was talking about, the weatherman was saying, hey, it's gonna be 100 degrees, well, that's going to be way too hot. So if we're going to, in Celsius, that'd be boiling. So if it was about 100 degrees Fahrenheit, though, outside, it's going to be a nice, Evan,
Weather.
hot day. So what kind of shoes would you want to wear then?
Flip-flops.
Probably want to wear some flip-flops, right? Okay, so I'm going to just hold one up now. I'm going to hold up this nice, warm pair of socks. What degree in Fahrenheit would you want, or would it be outside if you're going to wear some nice warm socks?
32.
Around 32 degrees, yes, freezing again. Good, you guys are getting the picture. And then if you were going to go out and probably put on your swim trunks, it's going to be around what degree in Fahrenheit, Evan?
400.
Around 100 or less, yeah, around there. It'd be good. Yeah, 80 to 100, perfect. So you guys are going to get the idea of where temperature affects us. You know, we're going to be twining it outside, we're going to be sweating, or we're going to be freezing, or whatever, or we're going to be comfortable, or we can just wear a t-shirt. That's a pretty important thing to know, because when you're getting dressed up in the morning and you see outside where the weatherman tells you it's going to be around 80 degrees Fahrenheit, you're not going to go out and grab your winter pants, because you're going to be sweating outside pretty bad. So, very important thing to know, to be able to take care of yourself, is to understand what the weather's like outside. That's another way that temperature is affecting us. Okay, so let's learn one more way that heat affects everybody by watching this cool video on Bill Nye the Science Guy did on heat. And so I'm going to put it here so that you guys can see it all, because it's kind of hard to see. And we're going to watch that and kind of discuss it as we go through, okay, you guys?
It's a dark screen.
Oops. Nah. Okay. Yeah.
Even cold things have heat. Things like snow, icy mountain lakes, and glaciers. They've got heat. Anything with molecules has heat. It's just that the molecules
It's okay.
are moving more slowly. The molecules are warming.
Did you guys hear that? He was mentioning that even cold things that have heat, everything has heat. It's just a matter of how much mass it has to contain that heat, right? So an example that he's going to bring up is that he's going to show a match, and he's going to show a big ice block. Which one do you think has got more heat, energy in it? Evan?
Grass.
No, a match, like a flame,
Match.
or an ice block.
Match.
A match, you would think a match, right? Because that's actually fire. But the ice block is so big that that fire is not going to be able to melt it, because it'll burn out before it even gets there. So there is an idea of this energy, this heat energy mass that you won't be able to see. But it's an idea you gotta have to wrap your head around. Like heat is in everything.
Here's a question. Which has more heat energy? This hot burning match or this beautiful ice sculpture of science?
Here we go.
Well, the match is hot, right? The sculpture's cold.
We're at the link we wanted to show you how we created our amazing new website with Wix. Now we know that having a great website is crucial because when we look good online, our brain just feels good.
Alright, well you guys get the idea.
They're actually fully designed websites.
This doesn't seem to be working properly for me. So, again, heat is everywhere. Heat is something that is very, it's gonna affect us the way we dress. It's gonna affect us the way that our solids and liquids and gases will all react to it. But also, but also it's just gonna affect our everyday life, right? Okay, so to move on from there, guys, we're gonna go on and we're gonna discuss a little bit about a little worksheet that I have put together for you guys to see if you guys can figure out the answers together as a group. I've got enough for everybody to take a look at, but this will not be too difficult because it is everything that we've been talking about. I'm gonna give you one pencil, you guys can either share or you guys can all write down one, but I want you guys to work together as a group to try to figure them out, okay? So you guys can read them together, and then I want you to work together to get the answers, all right? Go ahead and take a few minutes to take care of that. Make sure everybody's listening. Sabby, are you letting them participate? No, you guys can talk about it. Read the question and be like, okay, so where does it freeze? What is it? The first question was at what temperature does the water boil? So you guys, you can work together as a team.
It should be water.
Good job, guys. You might have to work a little bit harder together to figure out the last three. We came up with some of them on the board here, but if we can put down that list of three different ways that heat is transferred, you guys can come up with those as well.
The heat transfers and given it the heat transfers. Okay, so one will probably be it touching water, which makes the water turn into evaporation, right? Or yeah, okay.
Yeah, see if I can find the part in the video where it... Hey, yes. It's not fast forward.
And then things will happen to you.
Rate conduction of heat. Things
there
that
you
heat
go.
moves around the universe. Conduction. Conduction.
Okay, guys, check this one out here.
Convection. And radiation. Radiation.
You guys catch that? Let's
Conduction.
try it again one more time. This is kind of my favorite spot because this is the way that heat is transferred in the kitchen.
Radiation. So those are the three ways that heat moves around the universe. Conduction. Conduction of heat.
Almost right.
Convection.
And radiation.
Radiation.
Prediction and radiation.
Yeah.
We got all of that.
So those three things. So we have, what's an example of radiating heat would be, like if you just got a warm room, what would you be doing with your radiating heat? You'd just be like an oven, right? And then you got your convection where you're actually gonna be touching the heat source. So like when you're making pancakes, you put the pancake on the griddle and it transfers from the griddle there. And then radiation, again, that's through fire, touching the item and then toasting things. Okay, so how do we do on the answers? You guys get all three of those?
No.
So we had radiation, conduction, and the last one was convection?
Friction,
Convection.
radiation.
The ones we just talked about, he just mentioned on the three ways of transfer. All right, so we learned those three things. As we already kind of knew that though. We had these two, and then we added the conduction aspect to that, of transferring our heat. All
I
right,
haven't done mine.
you haven't done yours yet? Are you still trying to fill it out?
I'm waiting.
No?
I'm waiting.
We need more pencils.
You need another pencil? Did you get it all over there?
No.
It's all right. That's why you guys are working together. If you guys come up with the answers together, that's fine. Because you already knew them, right, Liam?
Yeah.
Is there any, so now that we've kind of learned these three different ways of heat transfer, in your house, can you guys give me an example of heat transferring in your house? Well, where would you get your heat in your house?
Furnacer.
The furnace, right? The heater in your house, you turn that on and it blows the hot air into your room. That's kind of like convection, right? I'm sorry, not convection, radiation.
Mm-hmm.
Hope I'm doing that right. Okay, cool. And then also the cooking, everything in the kitchen. So you guys have learned a few things about heat and how it transfers, and then also a few ways that it affects the temperature of items and what happens to those. Yeah, now you guys can take this information home with you. You can talk about it with your family. You can talk about it with your friends. And now especially you guys all know how to dress properly when it comes to going outside in the weather. But thank you guys so much for your patience and listening. And next time you guys come around, hopefully we'll be talking about something else that you're going to love to learn about, just like heat. Science is fun. Science is everywhere. And yes,
Like the solar system.
Like the solar system. Maybe next time we'll learn about the solar system. Thanks a lot, guys, for your patience and your focus and attention. And until we meet again, thanks and have a great day.
Bill Nye the Science Guy.